Hello, welcome. We're going to be looking at what is known as the activity series. This is our sort of final topic in this chapter, all about chemical reactions. So the activity series is going to be specifically and solely for our SREP reactions, our single replacement reactions. So when you're looking at this activity series, most likely when we talked about single replacement reactions, I used an analogy of like somebody knocking somebody else out of a dance, like stealing their dance partner, and then the other element's all sort of sad and lonely. So this activity series is going to talk about how reactive or how active a given element is. So when you look at that single element coming in and knocking out something in the compound, is it strong enough? Is it active enough to do that? So it'll list which element would be able to replace another element. So if we look at this activity series, it's going to be in your packet. So you might want to look through and find that in your packet, so you know, in reference. You're going to look basically like this, except your photocopy might be a little bit nicer and smoother than this one. But basically, we're looking at these list of elements. Most active element is lithium. Lithium will basically be able to replace anything in a compound. And just going down the list, so like if you had magnesium, magnesium could replace aluminum because magnesium is a little bit more active or a little bit stronger, if you want to think of it that way. But if you had aluminum, you would not be able to replace magnesium, so it has to be above that given element on a list. So let's look at a couple examples using that. So most of the time we'd be using just this long list from top to bottom of different compounds. So if we add something like zinc plus aluminum hydroxide, and we want to know, can zinc replace aluminum? So if I look at that activity series, I need to find zinc, and then I would need to find aluminum. So if I look through here, oh, there's zinc. There's aluminum. So when I look at zinc and aluminum, zinc is lower, it's less active, it's less strong than aluminum. So zinc cannot knock aluminum out of that compound and take its place. So in a case like this, since zinc is less active or less reactive than aluminum, all we have to do is write no reaction. Nothing's going to happen. Nothing will change. And that'll be it for that particular example. Another example, if I had something like sodium, and that's going to combine with aluminum hydroxide. So looking at aluminum again. So I've still got aluminum right there. Sodium now is higher on my activity series metals. So that means that sodium is going to be able to replace aluminum. It's stronger than aluminum. It can come into that dance and knock aluminum out of the way. So sodium is going to replace aluminum. So I'd have sodium combining with hydroxide. Sodium would be a positive one. Hydroxide would be negative one. So when I put those two together, just NaOH. And then aluminum's all by itself. Poor, lonely aluminum now. And on this one, we'd have to balance our equation then. If I look at it, I got 3 hydroxides, only 1, so I'd have to put a 3 on that, and then I'm going to have 3 sodiums as well, so I'd put a 3 over on the left side there. And that would be our balanced chemical equation. Another part of the activity series, if I look at something like lithium and it's combining with water. So how is that going to work? You might have noticed as you're looking at your packet or on the screen here, that along with this just list of stuff, there's other parts to this activity series. One of which is these boxes have some text in each section. So if I'm looking at like lithium here, lithium's in this section. So if I read this text here, it says it reacts with cold water and acids, replacing hydrogen. Reacts with oxygen, forming oxide. So the part we're interested in is that it says it reacts with cold water. So it will react with water. Lithium is going to be able to make this reaction. It's going to replace hydrogen, it says. So how is that going to work? Whenever looking at water, one thing we saw as we were putting together some of our chemical reactions and different stuff, frequently we would get hydrogen combining with hydroxide. You'd have HOH, but we wouldn't usually write it that way. We'd write it as H2O. But when we're breaking apart water, that's sort of useful to think about it that way. So when you look at water and you're breaking it apart, you're always going to be breaking apart a hydrogen and a hydroxide. That's how it's going to separate based on how it bonds. So when it says lithium is going to replace hydrogen, it's going to kick this hydrogen out of the way. So it'll be lithium with hydroxide, and then our hydrogen would be on its own. So we got lithium and hydroxide. Lithium is a charge of positive 1. Hydroxide has a charge of negative 1, so it's just LiOH. And hydrogen would be, if we looked in our packet at those common diatomic molecules, would be one of those common diatomic molecules. It would be H2. when you put that on its own. So take a moment to go through and balance that. Maybe you want to pause me real quick for a few seconds while you work through and balance that and see if you can get that figured out on your own. Hopefully you work that out on your own rather than just waiting for me to do all the work for you, because I hope you're not real lazy. That'd be sad. But if you do balance it correctly, you'd get 2, 2, 2, and 1. And that should balance everything out. Another example, let's say if we have cobalt and water. So again, we'd be finding cobalt on our list and then looking at what does it say about water. Okay, cobalt's down here in this section. So this section says, do not react with water. Reacts with acids, etc. But the part we'd be interested in does not react with water. So in this case, cobalt's not going to react with water, so no reaction. That'd be all you'd have to do on that one, since nothing's going to happen. The last little thing I want to mention here about this activity series of the element, we have looked at this whole list of the activity of metals. We looked at the text about whether it'll react with water and how that would deal with water when you break it up into a hydrogen and hydroxide. The last section here, just over on the far right side, a very short little sad sort of list, our activity of halogen nonmetals. So this would be if your single element is, let's say, chlorine. Chlorine would be trying to replace something else that is negative, because chlorine would have a charge of -1. It would want to replace a negative part of a compound. So chlorine could replace bromine if bromine were in that other compound. But chlorine would not be able to replace fluorine. So if you do have your single element is one of these four, you're just comparing it with the other three on this list, not our list of positive metals. So that would just be on its own separate list if you have that negative part, negative element trying to replace something. So that's about all I've got to say for you on this. So hopefully that all goes well. Go check out your assignment, see how that goes for you, and good luck.